Okay, this video is for lesson 4.3, homework packet, review packet 4A. So first problem, number 6, you can measure a car's fuel efficiency in miles per gallon, compare the number of miles driven to the number of gallons of gasoline used. The graph shows examples of distance against gas used in highway driving for 3 car models. So if you remember distance time graph, the steeper the slope is, the faster the whatever the object or whatever person or car moves. But this graph is distance against gasoline. I mean, gasoline. But still, if the line gets steeper, there is some kind of meaning. So let's take a look at problem number 1. So based on the type of car at right, which graph do you think represents the fuel used by each car? So car A, car B, car C. So obviously, as we all know, hybrid has the best gas efficiency. So let's think about each coordinate. Right here, the coordinate of here is 10 and 500. Right? So what does it mean by 10, 500? The x-axis stands for gallon, so the 10 means 10 gallons, and y-coordinate means, in this graph, it's a distance, so it's 500 miles. So 10 gallons and 500 miles, therefore you can move 500 miles spent using 10 gallons. Compare the car C right here. Car C here, the coordinate of this is 10 to 100. So that means you only can go to 200 miles using 10 gallons. Generally speaking, SUV is the least fuel efficiency. So yeah. So what's the answer? I don't want to give you too much hint. Part B. Find each car's rate of change in miles per gallon. So let me just do A. So A is whatever the car A moves 500 miles per gallon. So it's 500 miles per gallon, which is 10. So 500 divided by 10 is 50. So that means 50 miles. You can go to 50 miles per gallon. Spending one gallon, you can go to 50 miles. That's part 6. Problem 7. The time it takes to download files from the internet varies depending on the type of connection. The rate of transfer is measured in kilobytes per second. A trailer for a new video game is available online. It is 6 megabytes, which is about 49,000 kilobytes. How long does it take to download the trailer with the following connection? So let me do part A. Cable model running at 1200 kilobytes per second. That means you can download 1200 kilobytes in a minute. I mean in a second. In 1 second. So what would happen if you spend 10 seconds? What would happen if it spends how many kilobytes can you download in 10 seconds? How about 100 seconds? Or how about 60 seconds, right? So what do you have to do? So in order to download 49,000 kilobytes, how many seconds do you need, or how many minutes do you need if you want to convert it to the minutes? It's completely okay that you give me a second. So that's problem number 7. Problem number 10 and 11. Assume Katie bikes at a rate of 230 yards per minute. A. How far will she bike in a minute? In 5 minutes. So this is pretty much the way of thinking is pretty much the same as the previous problem. So 200 yards per minute. That means she goes 230 yards in a minute. right, in 1 minute, what would happen is 2 minutes. Well, you have to double it, right? That'll be 460. How about 5 minutes? How about, so what do you have to do to get 5 minutes? Every 1 minute, she bikes 230 yards, so yeah, that's a hint. Part B, how long will it take her to bike the length of a football field? A football field is 100 yards long. So obviously she's not going to take 1 minute because she can bike 230 yards in a minute. So in order to go to 1 yard, so it will be a little bit less than half. So what's the correlation? So find the rules between these two, okay, or these two. The relationship between the yards and the minute. Then, or maybe it's useful to convert this one to 60 minutes, and then find the rule between 230 and 60, so that you can apply the rules to 100 yards to get whatever the seconds. I'm sorry, it's not 60 minutes, it's 60 seconds. Wait a minute, what did I do? Okay. Part C, draw a distance time graph of Katie biking for 5 minutes. So draw a distance graph, did it? Like that. Can we convert this? Or whatever. And then, okay, distance time graph, the time is always on horizontal axis, because that's the independent variables. And then the y-axis is the distance. And this is the origin. And I would go 1, 2, 3, 4, 5 minutes. And then the yard should be, I would go probably 100 yard to 100 yard, So, and then plot the points. That's what you do for part C, and choose any 2 points on your graph, calculate the slope. So find a, you know how to do it, right? So the second y, in order to find the slope, you find out second y minus first y over second x minus first x. So that's what you have to do. Problem number 11. 1 minute after Katie started biking, 2 friends started following her. Nick bikes at the rate of 200 yards per minute. Lance bikes at a rate of 300 yards per minute. So if you think about this situation as a number line, okay, so then let's say this is a starting point, and then after 1 minute, so let's say this is a distance, and after 1 minute, Katie is at 230 yards away from the starting point. That's where Nick and Lance's are after 1 minute. But after 2 minutes, what would happen is Nick will be at 200 yards. Katie, wait a minute, 200 yards, and Lance will be 300 yard, right, after 2 minutes. And then Katie will be 460 yards, because in 2 minutes she goes 260 yards, 230 yards, 230 yards times 2. So question A, part A, will Nick catch Katie? If so, how long will it take for him? So how many minutes will it take? B, will Lance catch Katie? So that's the question. Well, Nick is actually slower than Katie, so the common sense should take place right here. So Nick is slower than Katie, and it started late. And Lance started late. However, he bikes faster than Katie. So think about that. Problem 12. Tamara travels 1 mile at 60 miles per hour. She travels the next 1 mile at 30 miles per hour. how long is her trip in minutes, and what is her average speed in miles per hour. So um, Tamara travels 1 mile at 60 miles per hour. So how many minutes does it take? So if you remember the formula, so we are trying to find out, so we know that the distance divided by time is what the speed is, right? So, just like miles per hour, per means the division, So 60 miles per hour in 1 mile. So, let's just, she goes so 60 miles per hour, that's the speed, right? And 1 mile is the distance. So we're just gonna replace that. So we'll have distance is 1 mile divided by what we don't know what the time is, but we know the speed, which is 60. Okay, how do we solve this one, right? Well, multiply both sides by t, so that long story short, we can cancel this out. So we have 1 equals 60 t. So the t is 1 over 60, right? So 1 over 60 what? Are we talking about minutes? We are talking about hour? We are talking about hour. So we are talking about 1 over 60 hours. Therefore, what's 1 over 60 hours? That's 1 minute, right? So it took for her, it took for her to, it took 1 minute for her to go to 1 mile. So that's how you find a hint. So what if next 1 mile she went slow, she slowed down 30 miles per hour, so what would happen?